Hey guys, this is Fred from Pretty Games, and this is a brand new series where we build an agar clone using Photon Fusion and Unity. In this series we'll be focused on server and client mode, so let's get started. So to make this tutorial shorter, I already created a UI for our game. So we can see that we have this canvas here, which contains a logo and a background panel with an input field and some other text field and a join button. It also has a in-game UI handler which references these different components, and this is what we will use to control the join part of our game. Then we have a background quad, which is essentially this background pattern here, and we're using a 3D quad which makes it more efficient to render because it's just a square. You can do it with sprites as well, but it seems to generate a lot of extra shapes. So we're just doing it with a 3D quad that is set at the position 0 and is scaled 50 times. And then we have our background, which is a material that is using tiling with this simple texture here, background grid. And if we open that one, we can see that it's just a square with sort of a border. So that's what we have as a start. Now, if you haven't already done so, you need to install Photon Fusion. And after you've done that, you need to go to Fusion and then go to Network Project Config and ensure that its physics engine is set to 2D, because this is going to be a 2D game. And the other part where you need to change something is if you go into the real-time setting, you need to apply the setting. You need to provide an app ID for Photon Fusion, which you can get on their site when you register. So now we can get started with adding multiplayer to our game. So the first part we need to do is get Photon Fusion up and running. So let's go into Scripts Network, create a new script, and let's call it Network Runner Handler. And let's open that in Visual Studio. So let's get rid of our start and update function. And the first part that we need to do is actually start a network runner. So a network runner in Photon Fusion is like the heart of the whole multiplayer system. It's required in order for Fusion to start and be able to create a client or a server. So we're going to provide a network runner as a prefab, and we're going to take that in as a serialized field. And we also will keep a local reference of the network runner that we're starting, or if there is already a network runner in the scene. Okay, awesome. And then we can essentially start programming this. So let's create an awake function, and I'm just going to cover this very quickly because I've already gone through this in our other videos regarding Photon Fusion. So we'll create an awake function, and what we will do is we will check if there is already a network runner in the scene, and if there is a network runner in the scene, we're going to assign that network runner in the scene to network runner. So then we know that there is already a network runner in the scene. Now in this game it's not going to be any network runner in the scene, so we need to create that. Actually let's add back start because we need that. Alright, so here we have our start function, and in our start function the first thing we're going to do is we're going to check if the network runner is null. And if it is, it means that we actually need to instantiate a new one. So let's instantiate a new network runner, and let's just call it network runner. And then we are going to set the game mode of our game. So we need to create a game mode, and it shows that it's not used and not assigned, and it probably doesn't know even what game mode is. Let's add using Photon Fusion. Oh, actually, it already added it for me. Okay, awesome. So then we can leave it as it is. And so we're starting up in client mode, but we want to make debugging easier as well. So when we are running in client mode, we are required to have a server running. And when we are developing, we want to do everything maybe on our single machine, and we want to run things in the editor to make it easier. So we're gonna have a check and see that, okay, if we're in the Unity editor, then we're actually going to use the game mode auto host or client, which means that if there isn't a server, then Photon Fusion is going to start in host mode and it's going to then connect a client. So it makes debugging easier. But if we are actually building as a server, a Unity server, then we want to start the game mode in server. Okay, perfect. So then we need to create another function that actually is going to start up our network runner, or initialize our network runner. So we are going to use a task initialize network runner and provide some variables: network runner, game mode, session name, address, scene, and then a callback for initialized. And the first thing we need to do is get a scene manager. So the scene manager is something that is required to, well, not required, but it's recommended to have a scene manager in Photon Fusion. So we need to create a function to get that. So let's create a iNetwork scene manager, or return an iNetwork scene manager, and we're calling it get scene manager, and it's providing with a network runner as a variable or as a parameter. And the first thing we do is runner get component mono behavior type network scene manager. So we'll find the first one in the scene if there is one. If there isn't one, then we are going to add a component network scene manager default, and then we are going to return it. So that gets our scene manager in here. And then we're going to say that, okay, our network runner is going to provide input, and then we'll just write out to the debug log initialize network runner done. And our utils debug log is a very simple function that wraps our debug message with just adding a timestamp to it with the message, so it's easier to read. Okay, awesome. And once we have written that, we are going to run their start game and then provide our start game arguments, which is going to be game mode, address, scene, etc. Awesome. So we have that, and we have this squiggly line here, which means that we have an error, which says that we are missing task. So let's just add that so it becomes happy. Oops. Here we go, using system threading.task. Perfect, so that works now. So then we can go ahead and actually start to use that. So let's call that function initialize network runner game mode, test session, network address any, and then we have a squiggly line under scene manager, get active scene build index. And that's because we haven't referenced that either. So let's use Unity engine scene management. Okay, so now we have that up and running, or actually we have initialized a network runner. So let's just add a debug log to that as well, so that we know that it's been done. So that's all we need for this to get the network actually up and running. So let's save that and go back into Unity. Awesome. So I've created a network runner already, or actually a prefab, which is completely empty. So let's add component, and we need our network runner. Here we go. And that's it. Then I've also created an empty object called network runner handler, which doesn't have anything in it. So let's add our network runner handler in there, and let's reference our network runner. And then let's hit play and wait for our game to load. And then our game is running, and well, it doesn't look like it's doing anything, but if we open do not destroy and load, we can see that we have a network runner, and it's actually running in game mode host. So that's all good. And if we look at our console, we can see that initialize network runner done and server network runner started. So that's all good. All right. So now we want to make it more interesting, so we need to add a player to the game. So let's go into projects and scripts, network. Let's create a new script and we'll call it network player, and let's open that in Visual Studio. So the first thing we can do is get rid of our update function, and then our network player is not going to derive from mono behavior, rather it's going to derive from network behavior, and it's going to implement the interface iPlayerLeft, which gives this squiggly line error because we haven't implemented that function yet. As well, make sure that Visual Studio is using Fusion. It's adding this automatically for me, but if you haven't, then add that in. Otherwise you're going to get an error on the network behavior as well, I think. Alright, and then what we want to do is we want to implement this iPlayerLeft, so we get rid of that error message. And we are going to do it as a public void player left, and take in the player ref and call it player, and then we are just checking if it's input to 30, then we are going to despawn it. All right, so that's what we're going to do. And another thing we want to do is we want to provide an easy access to our network player, which is the local network player. So let's add that as a variable, public static network player local. And what we want to do then is when we are spawning our player, we want to store our network player, and as well we want to add something to our logs that something has happened. So let's add a utils log player spawned, and we are curious if it has input authority or not. So input authority means that it can control that specific player. And if we do have local authority or input authority, then we are going to say that, okay, the local variable is actually going to be this script. So then we can keep track of that. And then we want to, well, mark down in Photon Fusion that this is the player object actually, with this input authority, and the object is, well, this. Perfect. And then one final part is we want to make it easier to tell which player is which. So we're going to change this transform's name into player, and then the object ID, which is going to be that network ID. So that's it. Let's save that and go back into Unity. So now we want to use our network player, and in network objects and the prefabs, I've already created a network player. But right now it doesn't have anything considering network in it. So what we have is a rigid body 2D, which is a dynamic rigid body, and it has a mass of 1 and a gravity scale of 0. And under it we have a sprite, which is this red part here, which is just a circle sprite provided by Unity. And then we have a circle collider set to is trigger, which is this green part, and that's what we're going to use to determine if we're hitting another player or if we are sort of eating food. And then under it we have a canvas, and it is using world space, so it's shows up in the world above our sprite, and it has an order in layer 1, so it's on top. If we have like -1, it's going to be behind it. So we don't want it to be in front of the sprite. And canvas scaler is attached, so it scales with this blob, so as it gets bigger, the text will get bigger as well. And then we have a text mesh pro, so that shows some name which stretches with some margins. So that's all we have essentially. Now we want to network enable this. So let's add our network player. And it gives this sort of warning that network behavior requires a network object. So let's press add network object. And then we as well need a network rigid body physics. Network rigid body 2D. and this gives us the ability to network our rigid body. And one really important thing here is that I've created a sprite as a child, so it shouldn't be up on our network object, but rather as a child. And the reason is we want to interpolate this, so it doesn't show up as sort of laggy for any of the clients. So we have this interpolation target, so if we set that to the sprite, then we are, well, not gonna have any lags. It's actually interpolating where it is based on our network object, so it's not entirely correct for the client, but that's how networking works. It's always like smoke and mirrors. There is always a little bit of lag, and we are dealing with it through interpolation, and there is the ability to predict things as well to make sure that the player doesn't really see that there is lag. I mean, even if there's a slight lag of 50 milliseconds, there's still a tiny lag. So by using the interpolation target, we are hiding this from the player, and it doesn't really matter for the experience. Alright, so let's save our network object here, and let's go back into our world. Then we need a way of actually spawning our network player in the network. So we need to create a new script for it. So good, let's go into under network, and let's create a network spawner. So create C# script network spawner, and let's open that in Visual Studio. So let's get ready to start and update, and it's going to be a network or a network runner spawner derived from mono behavior, and we are going to use iNetwork runner callbacks. So as we see that we have an error as well, and make sure that it's actually using Fusion. So the error is that we need to implement a bunch of interface members. So you need to create all of these. You need to implement all of them, otherwise it won't work. So let's start with the basic ones. First, we need to be able to spawn our player. So we need to take in our player, and we're using a serialized field network player, the prefab that we just created. And then we need to implement one of the first, well, many important things, but it's gonna be the onPlayer joined. So when our player is joining, this is the first callback that we're going to get. And we are writing onPlayer joined here in our debug logs. And then we are checking, are we the server? And if we are, then it means that we can actually spawn our player, because only the server can spawn things, and only the server can manipulate things in our sort of world. So we are using runner, spawn, and then we are spawning our player prefab. We're getting a random spawn point position. So if we open our get random spawn position, we can see that it's returning a random vector with some parameter x, some parameter y, and 0, and then multiplied by 0.9. So there is some margins on the side, and it's using the get play field size, which is this that just returns 50. So that's the size of our field. So if we go back into our network spawner, we can see that, okay, now we've implemented our network player, and we've spawned it. And yeah, that's all we need to do here. And then we need to provide all of the other methods. So I'm just gonna bring them in here. On player join, there we go. So on input, we'll go through that a little bit later. And then we have on connected to server, on player left, on input missing, on shutdown, etc. So you can see all of them, and most of them we are just writing a debug log that they have happened, but we're not doing it on every single one of them, because it's just going to add sort of irrelevant information to our debug log. So you need to implement all of them. Okay, so if we save this now and go back into Unity, and we can now use our network spawner. So let's go into prefabs, network runner, and select our network runner, and then add our spawner. and it takes in our player prefab. So let's use our play prefab, and then let's hit play and have it reload. So let's bring up the console, and we can see that, okay, we are sort of starting our network runner. On play joined happened, and we have spawned a player, and we can see in our hierarchy here that we have a player, and if we go into scene view, we should be able to find that player. So there we go, he is somewhere on the grid. Here we go. Awesome. So now we have a network player. We can't do anything with it, we can't control it or anything like that, but a player exists. So let's add some more functions to our game. Then let's add movement to our player so it can move around. So let's go in the script network, add a new script, C# script, movement handler, and let's open that in Visual Studio. Okay, so let's change the movement handler to be network behavior instead. Make sure that you're using Fusion, and let's get rid of our update function. So we want our little player here to move. So we need a input direction, and it's going to be vector 2, and it's going to be 0 as a start. And then let's just get it moving in some direction. So let's create a random direction. Input direction is going to be a random range between -1 and 1 in the X and Y direction. Then we want it to essentially move somewhere, and anywhere when we're manipulating network things, we need to use public override void fixed update network, which is referenced as fun as well. So this is where we can make changes to our position, etc. When it comes to networking, and only in here. So that's really important to know. And what we will do is we will take some movement speed maybe, or actually we can do that later. Let's take our movement direction, which is going to be our input direction. And then we want to make sure that we are normalizing it before we're using it, and then we want to move our object, and we move it by changing applying forces to our physics object, and before we do that we actually need a reference to it. So let's add a reference to our rigid body 2D, and before we can add, well, we'll need to acquire it first. So let's do a private awake here, and let's get our rigid body 2D. There we go, and then we want to apply a force to it. So when we have the movement direction, we are going to push it in some or in that direction by using add force movement direction multiplied with a movement speed that we haven't added, and the force mode is going to be impulse, so it reacts very quickly. And then let's add our variable movement speed somewhere, or actually let's just add that here when I think about it. So before we move it, let's do that, and it's going to be based on size, which we don't know what it is yet, so let's add a variable for that as well. So it's going to be U short, and I'll get back to that a little bit later why we have selected that. So U short size, and it's going to be a size of, I don't know, 5. Okay, so then we have our movement speed, which is going to be the size divided by the math power of size to 1.1 times 2. So this is a formula that I figured out works fairly well when things are growing and we don't want everything to be very fast or slow. As objects are getting bigger, they will start to move slower with this formula. Okay. Then we want to make sure that we are staying within the bounds of our playing field when we're moving around. So let's keep our player within that bounds. So once we have our input movement direction, let's check. If our transform position is smaller than x, or if the position in x is smaller than the playfield size divided by 2 times -1. So that puts us on the left side of our playing field, right? And then we're adding our sprite renderer, transform local scale .x divided by 2. And we're checking that we are not trying to move left. So with this, we can say that, okay, if this is true, then the player is actually trying to move outside the playing field, and we don't want that. And why we have our transform renderer, transform local scale, is we want this to work as our local object is getting bigger. Right, so then we need to do the same thing for all directions. So we have done it for left now. Let's do it for right and up and down. Okay, so then obviously we need a reference to our sprite renderer because it's complaining about that. So let's get that done in our other component. Let's add our sprite renderer and let's make sure that we are getting that one. All right. So this is going to be executed on all clients. So it is important to remember that only things that has state authority, which means the server, should be able to move objects and things like that. So now that we are running this code, it's actually going to run on all clients, regardless if we are servers or not. And this will create sort of a very strange jittery motion because the server is going to try to move it back and then the client is trying to move it away. So it's going to be a fight between the server and client. So what we want to do is this whole code here, we need to make sure that it's actually running on the server side. Okay, so let's make sure that we're doing this here and we're checking that, okay, if we are the server, object has state authority, then it means we are the server, or the host for that matter. If we are this server, then we are allowed to do this. If we're not the server, then we're not allowed to do it. So it will just get the information from the server that something has moved and it will be synchronized. So now we have ensured that only the server will be moving things, which is perfect. So then one final thing that we want is we want our camera to be able to focus on our actually local player. So we want to make sure that the camera can follow the player. So let's add a late update, and then we are going to check, okay, are we the local player? And we know that because we have object has input authority. Only our local player has input authority. We don't have input authority over other objects. And then let's store the aspect ratio, which is going to be the camera main aspect ratio. And we are taking the sprite renders transform local scale .x plus 7 because we want to look sort of 7 units ahead of the player and divide it by aspect ratio. So the ortho size is the size of the camera that is controlling like the zoom level. How much are we going to zoom? and we are going to lerp this. So we're going to take the camera main orthographic size, and we're going to lerp it between whatever size it has with this new ortho size with a time that makes it sort of a little bit slow, but not too slow. And then we want as well to move the camera around. So the camera's transform position is going to be a lerp from the current position to wherever the sprite renderer is, but with a -10, because that's where our camera is at the speed time delta time. Alright, so let's save that and go back into Unity. Then we want to start using our movement handler, so let's go into network object player, and let's add our movement handler. Movement handler. There we go. Hold on. Did we go? No. So yeah, here we go. Movement handler. Perfect. So now we're actually going to try this in a different way. We are going to build a client and run this as a server. So let's go into build settings, and what we have is we have our regular Windows client here, which we can build as, and dedicated server. So we are going to build this as a dedicated server, and we're going to run the client through the editor. Okay, so I'm just going to quickly build that. I'll be right back. So if we start our server, so I started our server build now, and we can see that yeah, there is a bunch of errors and warnings about shaders, but that doesn't really matter. So server network runner started perfect, and then let's just hit play on our editor, which is gonna act as a client, and we can see that, yeah, okay, here we go. Oh, and it is raising outside really quickly in the position because the movement handler is a little bit crazy. So let's actually stop that. And the reason why that happened is we forgot to actually limit the movement speed. So the physics is just pushing the player with in the direction, and it's just adding to the speed. We need to make sure that it can't go beyond a certain limit. But it was working, which was what we wanted to show. So let's actually fix that part with the problem. So let's open our movement handler in Visual Studio. So the problem is here, push the object in the given direction, and we need to make sure that it can't go beyond a certain speed. So we are checking that the velocity, the magnitude cannot go above the movement speed. If it does, then we are taking the velocity normalized times movement speed. So this ensures that it can never go faster than what we intended to. Okay, so good. Now another part that we want is the size of our sprite here. We want it to react to our size variable here. Right now we are just saying that, okay, the size is 5, but we are not really doing anything with it. So let's add a function called update size, and let's add it here. So the update size will take the sprite renders, transform, local scale, and it will take vector1 plus vector1 times 100 times the size divided by the largest possible value of our u short. So this will scale it according to the size, and yeah, then we need to as well call this. So in our start function, let's call update size. And while we're at it, let's actually network our u short here, the size of our object or the game or the player. So the size we want it to be shared on all clients because the clients are locally rendering all other players, so they need to know the size, right? So we are going to do a network variable here, and this is the reason why we have made it into a u short, because we want to sort of conserve bandwidth a little bit. So a U short is unsigned short, which is has a maximum value of 65,000, and it's fairly small for the network to handle. And then we are going to do our onChange. So we're going to call this onChange function. So then we have this error because we haven't implemented our onSize changed. So when the size is changed, this function is going to be called on all the clients. So we need to make sure that we are actually listening to that. So let's do a public, and it's important, it needs to be a static void onSize changed, and then we'll take in the changed movement handler and call it changed. And then to actually be able to call, because this is a static, to be able to reach into our non-static functions, we are using changed.behavior update size. So then we can reach into it. If we are doing just this update size, then we're going to get an error because we can't reference a non-static field. So that's just why we need to do that. Okay, so now we are reacting to the size of our player object, and it's going to be rendered properly on all clients with the correct size because we're doing our update size here. Then if we scroll up to our network variable, we're going to see that it's actually showing us an error, and it's because we can't set the size like this anymore because it's a network variable. So what we need to do is we need to say that, okay, the network size, we're going to use getSet like this. That removes that error, but then we need to set it into some variable to start with. And what we're going to do is we're going to add update size. Here we go. Let's add a public reset, so we can reset, and we're going to make it public, and we're going to set the size to 1. And when we are starting as well, let's actually reset it. All right, so that gets rid of our error. Then we're going to enhance our code a little bit to make sure that our player is staying within the bounds. Now we're just restricting the movement direction, which is okay, but let's make it a little bit better. So as well, what we will do is we will take our rigid body velocity and say that, hey, if we're trying to escape on the X direction, then make the velocity 0 and keep the direction or the velocity in the Y direction. So let's do that as well for all other cases to really make sure that it stays within the bounds of our playfield. And here we need to just shift it so it should be .x and 0. Alright, so there we go. Now what we want to do is we want to make sure that the player can actually control this. So instead of just sending it in a random direction, we are going to listen to mouse input and figure out in what direction the player wants it to go. So let's go back into Unity and add that. So we need to add a few more scripts. So let's create a C# script and network input data. And then let's make a folder, call it input. And then let's make another, well, let's have it compile first. And input, create input handler. Alright, so let's open that in Visual Studio. So let's actually start with our network input data, and let's get rid of all of this. And it needs to be a public struct network input data, deriving from iNetwork input. And the only thing we want in there is the movement input, which is going to be a vector 2. Alright, so save. Let's go into our input handler. And this is where we are going to collect our input. So let's make a variable, which is going to be a mouse direction. And then we are going to actually we don't need a start here. So then we are going to collect our mouse input, and we need to make sure that it's converted between the screen space and the camera space. So we need to figure out where in the world our mouse is. So we will do that by using the camera main screen to world point and feed in the mouse position, and this is going to give us a point in the world, and important is that we set the Z position to 0. Okay, so then we know where we are in the world, or where the mouse is in the world. And then we need to figure out, so if the player is here in the middle and we're holding our mouse here, it means that we want the player to move in that direction. So we need to calculate a direction, right? So what we do is we take our world mouse world point minus transforms position, so we calculate the direction of the mouse based on the player object. Then we want to normalize it, so it becomes between -1 and 1, and then we are actually going to leave it at that. Then we want to be able to supply this information to the network. So we're going to make a public network input data, which is called get network input. So what we do is we create a new struct here, network input data, and we feed in the information here and return it. The reason why we're not doing it in the update loop here is because this is going to be called by Photon Fusion at regular intervals, and we always want to get the latest information that we have, but we are running the update function all the time. So it's collecting the information, but all of a sudden it's going to get requested by Photon Fusion. So that's why we're doing it this way. Perfect. So then we need to actually start to supplying this information. So how do we do that? If we go to our network spawner, we have this on input that is going to be called by Photon Fusion, and it expects us to give back a network input. So what we will do is, not there, we will add a variable called input handler, which is another component here. And when we are getting this request to actually get our input on input, we are going to check, okay, is there an input handler which is null, which it is, we haven't acquired one, and the network local player is not null, then we are going to get the input handler from the network player local and get that input handler. And if it's not null, then we are actually going to grab that information from it. So we're going to go input set and then get our network input here. So that will force, or that will cause Photon Fusion to get the information from our input handler. But then as well, we need to actually utilize it in our movement handler. So let's go to the top here and say that, okay, if get input and then make an out network input data and the network input data, then if this is true, then we're going to override that input direction. So this get input will only be valid actually on the server side, but I'm leaving it like this because if we haven't gotten any input from the client for some reason, let's say that they are about to disconnect and something is going on, then at least we will keep on moving in the same direction as we had before. So this is a way of avoiding the game object of actually staying completely still if something happens in the network and we're not getting that data. So yeah, let's just leave it as it is and save and take it for a spin in Unity. So let's assign our input handler here. Add input and then let's try it out. Alright, so let's hide our UI canvas. Alright, so now we can see that we are able to move our player here. And let's see, we're staying within the bounds of the playfield. Let's go to the top, wherever it is. Hopefully we'll get there soon. And yeah, so we are staying within our bounds. That's perfect. And then we have some small error in our console. Add force assign attempt is not valid, and then it's divide by 0 or something like that. And this happens during the first few frames before actually our player has initialized properly. So we will fix that in a little bit, but that's an okay error. It just happens for a few times while we're spawning our player. So let's try that again now with the server. So I've compiled a new version of our server. I'm gonna put it here, and then we can connect through this one, and as well let's bring in a few compiled clients. So here we have our game, and let's just hide our canvas, and then I will start a few more clients. Here we go. And yeah, I can move around this little dot here, and then I have another client here, and yeah, now it actually is working. So we have our multiplayer version of our agar.io clone going, and let's see if we can meet them somewhere in the upper left corner. All right, going a bit slow, but we're getting there. Alright, here we go. So now we're at the same place. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.